This video is brought to you by Iona, North America's premier charging network. With unmatched commitment to elevating the customer experience, Iona is opening America's roads to all EVs, giving drivers the coverage they need, the reliability they deserve, and the amenities they crave. Hello and welcome to another Out of Spec Reviews video. You join me for a little sort of off topic, but I think just as interesting video to reviewing a new car, for example. We are talking all about power and energy, and specifically all the way from grid scale down to building level energy. Now, I'm at the Eaton Experience Center here in Pittsburgh, Pennsylvania. We've been here before. Eaton's a great partner of Out of Spec, and I decided to come here sort of last minute because I wanted to film some really cool power systems. Now, we've always talked about solar, battery storage, and some other cool power transformation and also distribution and storage on this channel, but we've never really shown it all working together. And I really think there's no other place in the entire country, maybe the world, that has as many different power sources integrated as cleanly in a demonstrated building as this right here. So we're gonna meet my buddy Dan Carnival, who's awesome. He runs the Experience Center here. We're gonna talk a little bit about this Bloom Energy hydrogen power generation situation. This is kind of why I came here as well, to check this out. I know you guys will have a lot of questions about this, and I've actually seen these out in the wild. And when I saw Dan got one here at the Experience Center, I was like, oh, we got to come over and check this thing out. And they've got cool electric trucks and charging as well. So it's just going to be like, if you're into power and energy, not so much cars in this episode. We're going deep with Eaton, as we always do. Everyone say a huge thanks to my buddy Caleb for shooting the intro to this video. This is Dan's new Silverado EV. He said that they ran out of work trucks, so he went for the RST. Yeah, they definitely did not run out of work trucks. He just wanted the nice one. And then last time we saw Dan, he was driving the Eaton F-150 Lightning XLT, so that's still here, still ripping, but he's been cruising in the Silverado EV with the big battery most of this time. And of course, they have their DC fast charging equipment, they have AC charging equipment, they've got so many things happening at this building. I came here to check out this Bloom Energy situation. We're gonna get into this later on in the video because I have a ton of questions on how this works. And my understanding is this is like a baby demonstrator. It's like, yeah, the real small version. This is grid scale, talking megawatts level expandable of taking natural gas, hydrogen, other stuff, and turning it into electricity to power data centers especially, but also buildings like the Eaton Center here. This is their car park, which is really cool. We've already shown this in previous videos, but a bunch of solar, a bunch of level 2 EVSEs with their smart breaker technology. I brought this Ioniq 5 over here that I rented, and yeah, just charging up to 100 because rental car companies will charge you if you don't return them full. I actually think that's a problem that like Avis and Hertz needs to work on. They need to accept cars back at low state of charge and charge them at their hubs, maybe with Eaton chargers. That makes more sense to me. Anyway, this is the Power Systems Experience Center. This is a playground for anyone who loves power. And I've been dabbling with the idea of making an out-of-spec sort of high power transmission, utility, grid scale, insert buzzword here, channel. And Dan's really the expert, so let's just talk to him. Well, I don't know what we're going to get ourselves into, but you're essentially going to see how they have incoming power, tons of solar, battery storage, capacitor storage, EV charging, hydrogen power generation, and how that all ties together in this super cool building. I think you guys will love this. All right, well, we just popped inside the building, and Dan, come on over here because welcome back to the channel.
Hey, Kyle. Great to have you back.
Thank you, as always, for taking time out of your day to show us around the most insane building I've ever been in. You are a mad genius with this stuff. I love it. First of all, I walk in and I see a DC fast charging screen here. You got to explain what's going on here.
Yeah, so we actually have, this is just a visualization. And you can see actually as the Silverado was starting to tail off and I unplugged it right there, you can see how much power it was using 150 kilowatts and it came down. and that's right where I unplugged it. So a lot of times we're just looking at the length of time and everything for the charging and discharging or the charging of these vehicles, and then we do it also on the AC chargers as well. So that's one part of the visualization here.
Yeah, let's pull up the AC charging actually, so I can go back to the main dashboard. Love
Yep.
this. And so that is simulating the solar with a bunch of level 2 stations here.
Yeah, so the green line here is the solar, and you can see it's coming up, and it'll be close to peak at the midday.
Yep.
And then the one vehicle that's out there, I think you said is yours, is actually charging here at, you know, about on that 7 kilowatt charger. So that's pretty straightforward.
Yeah.
And then the other thing that we have on there is the harmonic distortion thing, and we've actually found that the levels of distortion are really low. So the vehicle manufacturers are doing a really good job. I think they have to be below 10% total harmonic distortion on the current, but most of them are between 4 and 6%. So
Very cool.
the good news is they're very clean as far as, you know, the output. So
That's very awesome. I mean, this is such a 0.5% of what we have. Can we actually open this door really quick and
Yeah.
just show everyone later on in the video?
this is under construction part here, but yeah.
We're going to check out some big boy stuff.
Yeah.
So that's going to be awesome. And then of course you've got, you know, just simulating some real juicy cables and fuses and other stuff coming in here.
Yeah, so this would be like the main incoming service for a building like like you're talking about in your new building down there. It might be the first safety disconnect that's coming in. This would be a 1600 amp service, for example. So you're seeing like brown, orange, yellow indicates 480 volt. And this would be the main incoming service, obviously not connected here, so I can stand here and safely look at it. But this is what we do here, is show people stuff in a safe, controlled environment. The fuses that would protect you from an arc flash or anything bad that would happen.
So what I'd love to show the viewers today is a little bit about how you have all the energy integrated in your building, all the power coming in, the storage that you have on site, and you kind of have every conceivable power source that is reasonably possible in North America.
Yeah, well, one of each. We're trying to do a little bit of everything. Yeah, so
cool.
It is pretty cool, and we're actually going to do some upgrades in the fall. So let me just address it, as we're talking about the whole thing. You saw the solar canopy, and we have solar on the roof. So we're going to add and change those a little bit to get to about 100 kilowatts. So that's number one. If you take the utility incoming service, we divide it up into we're going to divide it into 4 branches. So one is the microgrid that I think we talked a little bit about last time. We'll show you again today. So that would be one branch, and that feeds kind of the back part of our building here. That has solar, battery storage, it has super caps, and it has a generator. So we can do that as one small part, a microgrid. We have the Bloom Energy fuel cell, which is really cool. We're talking about that today a little bit in more detail, but that's 50 kilowatts all day, every day. So that takes off 50 kilowatts no matter what on our building.
Right, and that's just the smallest thing they could offer you, right? Their stuff goes up megawatts level.
Their stuff is literally up to gigawatts. They can do utility scale stuff. We talk about solar farms. This is a farm of fuel cells that could do utility scale stuff. So they can tell you a little bit more about the details of that, but it's really cool and very scalable. So then we have, microgrid, fuel cell. The next part is our energy aware UPS. That's right over here in the other room. And this morning when I started charging the Silverado, it drew about 150 kilowatts on top of our building. So it went up well over 250 kilowatts for the building. And so what was happening is we don't want to put that demand on the utility. So what we do is we use the batteries in our UPS to do peak shaving. So we keep the building at 100 kilowatts.
That's the load you've selected.
And that's the load we selected to be sort of a reasonable amount. And then we discharge those batteries through the day. And then we do it as a demonstration here from 8 o'clock till noon. We could do it any time of the day, and depending on your rates, you would do it differently. But that part, so now we go from 250 kilowatts of load to 100 kilowatts that the utility thinks we're taking. And then we put the Bloom on top of that. So we're down to 50 kilowatts.
Wow.
Now, the next trick will be once the solar gets in and we get, the next thing is to add another big energy storage system we call X storage. That's going to be 500 kilowatt hours or 250 kilowatts. So we'll be able to keep our building net zero for a lot of the day, or at least, pretty much down close to zero for a decent bit, and even if nothing else, just control it down to something very reasonable.
Yeah, and I mean, if you chose a much more efficient electric car, you might actually be net zero. But Silverado's pretty thirsty, but that thing's awesome, dude. Do you like it, by the way?
I love it. Yeah, I mean, and again, it's fun to drive and everything, and obviously, it's a beast. It'll go. I love driving it. I mean, we have the F-150 and we have the Silverado, and I drive both of them. I mean, they're both super fast. I mean, I've told this to a lot of people, this is your passion, but I won't go back to another non-electric car because they're just too fun to drive.
Oh, totally. Yeah. But it is kind of cool that almost essentially you have to burn the batteries in those things to demonstrate the capability of your of your building.
Yeah, so the nice thing about that one, and it gets like the 460 mile kind of range on it now, I'll run it for a week and then I'll bring it in here and do the demo at the beginning of the week so we can show it. Yeah, so but it's a cool thing, and obviously that's a 200 kilowatt hour battery roughly.
Roughly, yep.
So if we go down in the other area over there, I'll show you the 240 kilowatt hours of batteries that are with the UPS.
Yeah, let's go check it out actually. Let's run down this way. So the building's pretty huge actually. I mean, you've got so many rooms, and I think we took everyone almost on a full tour, even in the refurbishing center on the other side as well last time. We won't go that crazy this time.
Yep. Let's just stop here for a second, because what we have here is this is the intertie for the Bloom Energy system. So on this meter, you would see 50 kilowatts down in this section right there.
Yep.
And that's what it's going to produce all day, every day. So the goal is to take that base load. And so when they put in a 10 megawatt system, for example, that's a base load. And then the other loads can vary around that. And Rebecca will describe a little bit of sort of how they can use it in microgrid applications and load following and stuff like that.
Yeah, I guess that Bloom Energy, you would use it for a similar, load profile as like a small nuclear station.
Yeah, it's the base load, and then you have the other variable sources on top of that. So whether it's the utility that you're relying on, or in our case, battery storage or whatever, but yeah, it's all going to be kind of adding to that.
So that's cool. So that's where that comes into the building.
So that's where that comes into
the picture. And we'll talk about that later on, but that's just ripping 50 kilowatts forever, basically.
Yeah. Now,
we've
what
got
we're doing
cool
here,
screens.
so this is, and I don't know if, so right back here is where I was charging the vehicle, and you can see the blue is the building load. That went actually off the screen. We were up above 180. I think it was 250 kilowatts.
Okay, nice.
But the yellow is what we held the building to. So the yellow is right around 100 kilowatts. And right now we're actually not using more than 100 kilowatts. So we're using 90 right now, and the building draw is a little bit higher just because of inefficiencies.
Yeah, so I can see we're at like 89 kilowatts.
Yeah.
Yep.
Yeah, so if you look back at this point, this is a good example here. We're held at 100. We took a little bit out of the battery here to supplement for the blue. So the purple is the battery, the blue is the actual load. And you can see, again, when we were charging the vehicle, even though that went way up, we took power out of the batteries in that purple, and so we used about peak of about 150 kilowatts, which is what we use for the car.
And these are the batteries,
and these are the batteries. So this is 240 kilowatt hours of batteries, and that's the UPS back there. That's a 600 kilowatt unit. So I could go up to 600 kilowatts of output power, or I could use it as a regular UPS to feed my building, which is what we're doing on a normal basis. So if we lose power, its first priority is to take care of the building. But as a second priority, since we're using lithium-ion batteries, which can take many, many, many operations, we can use them to discharge back into the system. And that's where the energy storage systems come in, like the new battery system that we're going to put in that's 250 kilowatt hour inverter, but a 500 kilowatt hour, or sorry, 250 kilowatt inverter, 500 kilowatt hour battery. So it'll be double the size of this, in a more compact thing outside, liquid cooled and so forth.
What is Eaton's role in those? Because Eaton is like a company that does everything, and every week it seems like Eaton buys a new company that does something else really cool. What is the current Eaton offering for energy storage?
So we have an X storage 1 megawatt block system that is out of our group that does the UPS systems as well. And so we have those blocks to put into microgrid applications or for vehicle charging type applications, and you could go as big as you need to. That's where the real beauty of this lies, because as you know, with vehicle charging, and that's a perfect example of it, where it just went up for a half an hour. But if I let that set my demand for the month, that's a problem.
Yeah, so we screwed.
Yeah, we're all over it. Now, the reason we're doing it with our UPS as well is because these massive data centers that are buying 300 megawatts of power are running a lot of that power through the UPSs. So they're also asking us, hey, we have lithium batteries. They're good for 20 or 30,000 operations. What else can we do with it? Can we sell power back to the grid? And that's also our part. And then we're looking into, we just bought resilient power, so we have A lot of work in that space as well for doing some larger DC applications as well, and more to follow on that later.
Yeah, that'll definitely be kind of a full video we should do if the viewers kind of like this stuff, because that's really cool. Data centers and EV charging seem to be the two new big loads that are like of the 2020s.
Yeah, I would say when somebody comes in to talk to us, say they're interested in new technology and all that, it's mostly utilities as it relates to vehicle charging and other big electric loads, and data centers. Those are the two things that people are most concerned with. So as you think about adding more vehicle charging and the demand on the grid for like 10 or 12 hours, or in this case a half an hour of very intense demand, then you can hear it just kicked in.
Yeah.
So it's just starting to get above that. So it's starting to discharge the batteries. It's just starting to exceed that level. But if we waited a little while, maybe the load would go up well over,
Yeah, it's barely covering.
It's just barely covering its losses right now.
Yeah.
But anyway, yeah, really cool technologies and stuff. And then there's also supercapacitors that are for short-term stuff. So these batteries are for hours or an hour.
Right. These are the normal, sort of bulk storage, energy storage lithium batteries.
Yeah.
Capacitor is something I don't understand.
So normal capacitors.
Can we show everyone those?
Yeah. So normal capacitors would be microfarad rated. Supercapacitors, or sometimes you call them ultracapacitors, are farad rated. And all that means is they're much more dense energy storage. So like one of these blocks is rated 130 farads and 62 volts. So if I put them in series and I could get 480 volts DC, I can supply the bus on a UPS and ride through, say, 30 seconds, or 10 or 20 seconds, just long enough to maybe get my generator going. So the other thing that we're doing with these today is, as you know, like AI loads, we're all doing these searches and stuff. The AI loads are very demanding, on, off, on, off, on, off. And as that happens, you don't want to kill batteries. So supercaps can take millions of operations, or 1 million operations. So they can take this charge-discharge cycle very rapidly. Now, when you're doing vehicle charging, I mean, I think there are supercaps in vehicles for like the quick discharge and regenerative stuff. But I know in the fuel cell, Rebecca will talk a little bit about the supercap application there. And what that does is basically bridges the gap of when you lose power on this base load to recover. And we can do 100 kilowatts for 30 seconds with those supercaps. So it's really just bridging the gap for short-term stuff.
So just out of curiosity, obviously I think most of our viewers are pretty familiar with a general lithium cell. They'll last, easy 10 years, something like that, to 70% retention and, blah, blah, blah. What is the actual durability and lifespan of a supercap? Do they lose capacity? Do they lose power output? What happens to them as they age?
So again, it's not like the electrolytic kind of capacitors that a lot of people worry about drying out and stuff like that, but it's more of it's more similar to that electrical, the battery piece. And so, but the degradation is not significant. Again, 1 million operations is nothing for these guys.
Wow.
So you're talking a 10 or 20 year life cycle, and depending on the application, just like with batteries, like if you do full deep discharges, 10 or 20,000. But if you do those little discharges we're doing, we could do many, many more than that.
They'll pretty much last forever at that point.
So these guys are able to toggle that, that cyclic load, or with the Bloom fuel cell, we can do that really quick and get power back on quick.
Dang, so that's really cool. So you're seeing a lot of data centers go with, a Bloom system, let's just say, plus energy storage, but potentially plus this to handle the big shifts.
As we're moving forward, it's not happening today in massive form, but they're definitely considering a lot of this stuff and we're doing a lot of testing around the AI type loads that are going to take this power on and off. So this is where we're, using this technology to kind of supplement the existing technology.
That's really cool. Really cool. Now you've got just like cool stuff everywhere in this building. Can we run over just as sort of an education piece to everyone? Actually, I guess this really sums up everything happening with the building at the moment.
We'll do a big picture of this later.
That would
if
be
you
great.
picture this, we'll do a bigger version of that'll have the utility at the top, and then we'll have the microgrid, the fuel cell, the battery storage, and the energy aware UPS, all as sort of second level things. And then of course, what's the important part is the building loads down at the bottom, right? So the building loads are really what drives all this stuff, whether it's vehicle charging, whether it's lighting and air conditioning and so forth.
Sure, that sounds really good. So I think what we should do is we should run to one of the other rooms that you have where you've got some big breakers.
Yep.
And just show people like what are data centers actually putting in?
Yeah.
What do EV charging like? If you put in a bank of EV chargers that are like 60 stall superchargers are not uncommon. What does some of that switchgear require in terms of breakers and stuff like that?
Yeah, let's talk about that, because even if if you're talking about, we can cut through.
Yeah,
right
sure,
here.
sounds great.
Yep. If you're talking about large, 300 kilowatt or 500 kilowatt, I mean, those scale up pretty quickly to massive voltages and power levels. So what we're doing is we're moving more from the traditional, 208 normal commercial building, definitely to 480, and then we're moving towards even medium voltage, which is the resilient power thing, bringing power in at medium voltage. So this would be a transformer that would be, let's say, in this case, 13.8 kV or 34.5 kV like you have in your building, coming down to 480. And then we have these very large breakers that are, this is a 3,000 amp breaker that would feed a section of this switchgear. So that's like the main breaker in your house, and this is the feeder breakers, but they're very large breakers, and they make lots of noise.
Hell yeah. So as a reference to our audience, there's a new charging site that went up a couple of years ago in San Francisco. It's an Electrify America charging site. And it's the first that I've seen like a charge point operator actually do their own medium voltage interconnect. They did not rely on the utility to provide it. They had their own connection in the building. And it had a, very similar, may even be this exact transformer that was feeding switchgear that looked kind of like this. Now I couldn't take photos of it because they didn't want anyone to see it for some reason. But here we've got, this on display.
Yeah, so that would be like, for example, the main breaker, and then these feeder breakers could be, let's say, 1600 amp feeder breakers. So this could feed like that switch that we saw in the front, and then that switch would feed
a couple DC chargers.
So roughly, if you look at amps versus power or kVA, it's like if you had 1,000 kilowatts of load, it's 1,200 amps. So
got it.
So like 1,000 kilowatts of load is two 500 kilowatt things, maybe three 500 kilowatt big DC chargers on one of these breakers. That's kind of the scale of what you're talking about.
And the other thing is, the new version of Tesla superchargers, for example, the version 4 chargers, they're 1.2 megawatt cabinets that feed 8 stalls. And then they spread the load. We've got some thunderstorm simulations happening over there. It's all good.
Lots of happy chaos going on here. And then also, so we have this one. I've showed you, I think I might have showed you this before, but like, this is sort of the protection part of it. So there's lots of things that can happen. We call it arc flash with explosions and stuff. So if you look at that little wrench on there, if I pull this down, we create a simulated arc flash, and then we have our little protector over here. And this thing is kind of like an electrical airbag. So think about like if you have an airbag, you hit the wall, the airbag goes off, it deflates. This thing only has to hold on to the electrical energy until this breaker trips. So this operates in like 2 to 4 milliseconds. This operates in 50 milliseconds. Very fast, but still we need to hold on to some of that energy.
And this is an arc quenching device. Very cool. I don't think I've ever heard of that. That's really interesting.
There's so much new technology because everything's getting bigger. And it's one thing to mess around with low power, low voltage stuff and whatever, but when you start talking about this stuff, there's very dangerous situations that can occur.
And this is the stuff that's needed for those big charging sites. When we're talking 60 stalls, 100 stall chargers.
Absolutely.
I mean, we're getting into some big power.
And why switchgear is because it racks in and out. And here's an example of this racking mechanism, but you can kind of see down inside here. These are they call them finger clusters that grab a hold of the electrical bus back there. And so those rack in and out. And why do you do that? Because just like your car, you have to work on these things because they have mechanical parts, and we have to make sure they're going to work when you need it. Because you're relying on this as a big deal.
You'll refurbish them here as well.
Correct. Yeah, you saw that last time. Yeah.
So that's a really cool situation. I mean, this is the behind the scenes stuff that you don't see too often. Now, There is new tech that Eaton is working on that we're actually going to try to display at the out of spec track, which is the medium voltage solid state transformers.
Yeah.
And those essentially are like inverter based transformers that can then directly supply charging equipment.
So you'll come in with AC at, well, you know, medium voltage runs from essentially 1,000 volts to 69,000 volts, but most of the time you're at, you know, 13,000 volts or 15,000 volt class, we say, or 38 kV class. And that stuff is going to come in directly, and then you'll have different ports on the output that'll be, you know, AC output for some little loads, and then DC output for some of the bigger loads, and or, you know, some additional AC. So there's some really cool stuff going on in that space.
Yeah.
And just to kind of complete the picture, this is medium voltage switchgear, so that is low voltage. So you might need.
So this is low voltage.
Yeah. So that's low voltage 480. This is medium voltage. That one breaker fits in this section. So like to your point, if I had one of those transformers, or say 5 of those transformers, I would need a breaker for each of those transformers too. So it scales up. And as we talk about data centers and all these really big things and the big charging systems, each one of these breakers now becomes a host for that big transformer that then distributes power.
Totally. And would you say most of this is what would be installed on site for like an integrated system, but can they be outside? Like
they can be outside. Yeah, there's outdoor versions of this. And the other thing to think about, and I think for your viewers to understand for the really big systems, is it is cheaper to buy power at medium voltage. Not as many people are trained to do it, but sometimes the utility will give you a rate difference that's lower. So if you're going to buy 200 megawatts of power, you probably want to buy it at medium voltage so you can distribute it yourself and also save some money.
Yeah, I mean, I'm thinking about some of those charging parks, like especially on I-5 in California, for example, where you just know in 3 to 5 years time, they're going to be full ripping all day, every day. You may as well go big and save on that situation. And then if you were to tie in solar, if you were to tie in other technologies, how does that actually work with the switchgear? Are there inputs for those at this level?
So, you know, electricity doesn't care about, you know, we talk about a lot about bidirectional stuff. Electricity doesn't care about really where it flows if you connect it into here. So if I took one of these feeder breakers, I could feed a solar array out of this, and the power could flow in. So my main breaker then would show the difference of all my loads minus my solar.
Got it.
So it's just a differential of the ins and outs.
And it's fairly simple to do that. You just load it on a bus, and then this is pulling from the bus.
Yeah, you just have to think about what you're going to do is you're going to put extra power into there. So the bus has to be rated to handle that extra capacity, because if it's rated, let's say 4,000 amp bus, and you put 1,000 amps of solar, you could actually draw 5,000 amps of load.
Right, and it's not rated for that.
And the bus wouldn't like it. Yeah,
and
so there's special considerations, but not.
But there's software to control that? Is that
there's
how that would
designs that you would think through and logically kind of go to, okay, this is what we're going to add. So
yeah, and I'm also noticing like you have touch screens on switchgear now. That's kind of new for me to see.
Yeah, these screens have lots of really cool stuff in it. So this is one of our latest versions of the switchgear, and it has, we bought a company called Exotherm, so it does online continuous monitoring, so you could do thermal monitoring. So instead of doing a thermal camera, like it'll watch the gear all day, every day.
Oh, wow.
Relatively inexpensive, but it'll do it, and then you can display it here.
So you've got all of your phases, temperatures right there. And why would that be important, just in case you're working it too hard?
Well, what happens is if you did a thermal scan and you didn't know there was a loose connection on the back here, you know, these are all field installed on the back, so you have wires coming in. If you didn't know that that was loose, it could burn up and cause a fire. And when this stuff goes down, because it's so big, you're taking out big parts of the power system. So you really have to be proactive to make sure it's going to be okay.
So if you see a temperature rise in one area, you know to go and check that.
So it looks at temperature, humidity. We also have what we call Gear Guard in there, which is also looking at other factors, you know, related to the switchgear. And then these breakers actually have a sort of a health status. So like the vehicles now, you have sort of a health check on those, and it says, hey, I don't like this, I shouldn't be seeing or feeling this or whatever. After a certain number of operations and stuff, they go into sort of this health check mode and says, hey, and so that can be displayed as well. So lots of the sensors that are available, just like in electric vehicles or any vehicle, are amazing. So you could think about gear now doing sort of this self-check to make sure it's going to live through any kind of weird stuff.
It's so cool. I mean, very, very rarely do we ever get the opportunity to see stuff like this really at all in the public, because most of the, at least, data center probably is indoor, but a lot of the charging stuff is outdoor, and all we see are just big boxes.
Big gray boxes.
And like, this is what's behind the big boxes.
Yeah. This has a big heavy duty door, and it has rainproof, protection on it. And also, there's actually heaters in the back of this stuff. But there would be heaters in the back of that too, because the temperature and humidity, the big fluctuations can really cause this stuff to get damaged, and so what we do in indoor stuff is we put those heaters in to run it, to make sure before this stuff is energized, to keep it at the right temperature. When this stuff is creating its own heat from losses and whatever, it'll keep it dry in there. But if you have really light load conditions, let's say, and it's in a kind of a temperate environment where you could get humidity, you could really damage some of this stuff. And then you get flashovers like the wrench thing in there, but on a bigger scale. And,
Oh, damn. I didn't even know that. That's crazy. So it's actually a lot of the outdoor equipment, you need to factor in actual temperature and humidity. Because what happens in the desert when this stuff gets really hot?
So that they're intended to be in certain temperature climates and stuff like that. So you could either derate it, or you can buy the equipment that's rated for that higher temperature. So it's not the direct temperature itself as much as the unusual temperature. So if it's expected, now you'll see a lot of solar fields, they paint the boxes white so they get reflective, so you get less, less actual heat that's absorbed.
Sure.
But that does play a part of it. But the humidity piece, the overnight stuff, that's where you can have some risk. So again, online continuous monitoring makes a big difference. Yeah.
Damn, this is so cool. Well, I really appreciate the high level tour. I think we should do a YouTube channel together one day.
I think we should.
And just do like breaking all of this stuff down through a series that is hopefully never ending, because it's getting cool.
I mean, educational wise, I think a lot of people don't get to see this. I mean, this is our 20th year of the Experience Center here, the Power Systems Experience Center in Pittsburgh, and we have the one in Houston that's almost as old. Like, we've got a lot of really cool stuff, and frankly, like, it's literally looking behind the scenes, like you said. From an educational standpoint, it can be scary stuff, but if you bring it into the sort of the realm of what people can understand, I mean, it helps a lot, so that when you do design the next system, you know what to look for. Yeah.
Totally agree. Well, thank you again for showing us around this. As always, I've got to come back sometime soon. I'm going to meet up with the Bloom Energy guys, because I guess maybe before we go with them, what did you approach them? Did they approach you? How did that work?
We work together. So we sell them stuff like this, or the switchboards that you saw over in the other room, and frankly, they've been great to work with. They're very thorough. When I do stuff here, I have sort of like, I have to put stuff together quickly. But they made sure we went through all the details of it. So it was cool to work with them. And then as a demonstration project, I didn't understand really anything about fuel cells.
Yeah, me either.
I mean, I love it. It's a really cool technology that I kind of almost looked beyond at first. But now that I look at it, it's going to be the future for a lot of the stuff, because we need multiple sources of power. Like, and this bridge power thing that they might want to tell you about is real. Like, I see customers come in all the time and they say, hey, we need all this stuff because I'm going to build a data center in 2 years it's going to be up and running. And they go to the utility, and the utility says, well, we can't build you a line for 5 years because, we've got all this stuff. But if you build the plant, we'll rush the line along. So this bridge power is getting the power to them quickly, so they can start up when they're ready to go. That's a big deal.
We felt it even in our last location. To put in a single DC charger was a 24-month wait.
Yeah.
If you're going to build a data center that needs constant megawatts of power, you need some juicy lines there. Yeah. And the thing is, like, the demand for power right now in localized areas is getting crazy. You have housing complexes, apartments, data centers with AI is really ramping the load, and of course EV loads as well. So just having different power sources is why I wanted to shoot this video. I had never really, I've heard of the Bloom Energy stuff. I knew it was hydrogen. I've seen it in LA before at the convention center. I didn't really pay too much attention to it, but I saw your post on LinkedIn about it. And I was like, oh, Dan's got this thing. I got to come check it out. So that's why I came.
Great. I'm glad to have you here. And honestly, like, I think if more people understood it, I think it will become even more of a common thing. I just think it makes a lot of sense. Again, I really didn't know a whole lot about it, but I love learning, so I'm all about it. Yeah, I'm pretty excited about it.
Very cool. Well, I'm going to pop out with them. Thank you as always for joining for another video. And we've got so much more to film, dude. It's crazy. All right, guys, you join us outside of the Experience Center now, where this is kind of why I came all the way over here to check out this Bloom Energy power system situation. Now, I have actually seen one of these, and it's in one of our LA auto show tours where we were outside and we're like, what is this? We've got to learn more about this. And when I saw Dan had one of these getting installed at the Experience Center, I said, you know what? I've got to go to Colorado today. Let me just swing by Pittsburgh, you know, sort of a flight plan. So I popped in here to check this out. Now, what I really didn't know was everything. I don't know anything about this, and I'm learning today as we go. First of all, I'm learning more about data center needs. I'm learning more about bridge power needs, and it's really cool to be able to see interesting and innovative solutions to a real problem, which is getting reliable, clean, high power to major sites that need it. And this is Rebecca. Rebecca's an expert in this. She is, you know, I would say one of the real, you've told me everything I know about Bloom Energy. We could say that.
That's right.
And Rebecca actually lives in North Carolina, which is cool. So we're practically neighbors.
Absolutely.
And thank you for coming all the way out here to share with us and our viewers a little bit more about Bloom Energy. My understanding is this is a really miniaturized baby version of what you guys typically install.
It is. It is. I call this a demonstration product. We don't really sell this small version out in the market. It's just a portion of it so that we can highlight here at the Experience Center.
Perfect. Well, I'm glad it's getting some work in. This is what it's for, making videos, having Dan play around. I think Dan just wanted to play around with it.
Yeah, he loves his toys. This is one of his latest toys. So.
Awesome. So what's cool about this is you essentially can take in a power source, which we'll get into, because you can take natural gas, hydrogen,
biogas.
Yeah, exactly. And then convert it through a series of processes, which kind of is, each one of these pods is a different process that it goes through. Then you can output DC, well, to an inverter, which then outputs 480 AC to a building or a substation. Now, some of the sites that you've done are in the megawatts level.
Yes, yes, we have. In fact, we are utility grade in scale. A lot of our customers are data centers, are just driving all the business these days in utility scale because power is so hard to get these days to power those big data centers.
Yeah, and that seems to be the real key here is when you put in a new data center, or if you need, I don't know, whatever power needs you have, getting high power there is pretty difficult. But getting natural gas, for example, is much easier.
It is. It is. And natural gas is what runs in the pipe currently today. So we use natural gas as our fuel in most of our installations. But it's actually meant to run on hydrogen until we get to a hydrogen industry where it's in the pipes. We've got natural gas, so we use that hydrogen to make the chemical reaction and make the process work.
Yeah, and your hydrogen process is really unique. It's a little bit different than like a fuel cell in a car.
It is.
And so we'll get into the basic high levels of this. And then if the viewers want to see more, I want to come out and visit you guys.
Absolutely.
And do a real nerd thing. But let's actually run through the process of what's happening here, which back here I can see we've got some input feed. So can you explain roughly what's coming down and what's happening here?
Absolutely. This is the natural gas feed coming from the utility, the natural gas company. And we need about 15 psi to run the equipment and to create the chemical reaction. So depending on where your natural gas connection is, you might have to step it up or step it down.
And that's doable then?
It is. It is. And they had to do that here, exactly.
Yeah. Dan only had half a PSI.
Half a PSI, yeah.
He's like, that ain't going to work.
He wasn't happy when he turned it on. He had to go get some more pressure there. So.
Yeah, yeah. And I guess so natural gas is pretty easy, but I guess the one thing that my viewers would like to know, and I was curious about as well, is pollutants. Obviously this is cleaner, but it still has some carbon output because we're not using straight hydrogen.
That's right. So natural gas, CH4, is got carbon in it, so you're going to have carbon in the emissions, but it's very efficient. It runs at anywhere from 53 to 65% efficiency, so it's using 30% less natural gas
than like a generator would use.
To generate the same amount of energy. So in that sense, it's less carbon intensive. We can also do carbon capture, so we can capture that carbon And with government credits, we can sell it or store it, and that just helps in the value chain. So we can do that as well. It's a very pure stream of carbon, so it's really good for that.
And we'll definitely explain how you can get up to over 90% efficiency.
Absolutely.
Which I think is what really blew my mind.
Yeah.
Is because you have like such a complicated situation that generates a lot of heat after the energy is created. You can do a lot with that heat, especially if it's placed in an area that needs it. So we'll talk about that for sure. So you've got the natural gas in this case, and would you say that's the case for most of these installations, natural gas at the moment?
Absolutely. That's what's in the pipe. So it's actually most of our installed base is running on natural gas. Some instances we're running on biogas that's been treated to natural gas kind of quality that feeds it. We have some demos running on hydrogen, but it's very expensive to bottle and ship in hydrogen.
And then you're driving trucks over every day.
Every day. Yeah. So it's not really economical until it's in the pipes. But yeah, we can operate on hydrogen.
So maybe you can walk us through each cube and what they do. I'd love to one day pull the covers off of this. I tried already, but it's pretty secretive is what it sounds like.
We've got a secret fuel cell that our CEO doesn't like to show, but we can talk about the modules. They look all the same, but they're very different. The first module we call a fuel processing module. This is the first unit where the natural gas comes in. Inside is sulfur beds. We have to remove the sulfur, and sulfur is what you add to natural gas to give it that smell. Because you want to know if something's leaking. Fuel cells don't like sulfur, so we like to take that out.
Okay, so this is sort of purification right here.
Absolutely, yeah.
Okay.
And then the next module where the Bloom Energy logo is our inverter. One thing about the fuel cells, it generates DC voltage. And there's a lot of talk about that in the industry right now because data centers run on DC. So why do you need an inverter at all if you just can take DC right to the rack? So we're investigating that as well.
Okay, because what you're doing with the inverter, this is kind of the last step of the process. The thing is, this isn't really done in order.
Yeah, it's not shown in order here.
However, what this is doing is this is running at 50 kilowatts wide open right now. And that's what's just base load feeding this building.
It is. And this whole piece of equipment is generating that 50%. So fuel processing, this is the inverter that just takes the DC and takes it to AC 480 to the building.
Right.
So this is just an inverter module right here.
So that's pretty cool. We're familiar with that from the EV charging world. We know all about inverters and driving electric motors and stuff. You can create DC and make it into three-phase AC, and in this case, you're running 480 three-phase.
That's right.
That's very cool.
That's right.
And then what happens
all
down
the
the line?
magic is right here. So this is our this is our power module, and the power module is opposed to the fuel cells. So the fuel cells inside, again, this is a 65 kilowatt power module, which is our standard kind of power module. They're only generating 50 kilowatts here at the Experience Center.
It's like 80%-ish.
About 80%. Yeah. And then the cabinet next to it is kind of a spare. And fuel cells, our whole job is to get the cost down and the life extended. They last about 5 to 6 years, and you have to kind of replenish them. But it's really cool because they degrade slowly. We can monitor them from remote, so we can tell when they need love, and then we can come out here and hot swap it. We don't have to take the system down. We can just put a new one in.
That's really cool. Now, this is running super hot, right? Internally.
Internally, we call it the hot box. It's 800 degrees C.
Damn.
But it's not 800 degrees C outside. No? I think 80 degrees C at the top when it's exhausting out.
Yeah. And what is the startup procedure of something like this? Because, I'm not a hydrogen expert. I know things can freeze in the cold temperatures. What does it take to actually start this thing? Because it's not like a car where it can just go instantly, right?
No. With the startup process, it only needs a little bit of water, which is one of our other advantages. It actually is water positive throughout the operating, so that's pretty cool.
Right, so you actually expel just distilled water.
Yes, exactly. So that's pretty cool. It takes about 16 hours to get it to start up. But once it's running and it's warm, we don't have to worry about freezing. Snow can accumulate, but the vents are high up on the ground. We like to keep the vents because it does like air. We want to keep debris away from the vents because like air and water is and fuel is what makes it run. But yeah, it's the startup time takes a while, but it's supposed to run all the time, 24/7, 365. It does not go down unless the gas line goes down.
What's really cool about this is, like you were mentioning, this thing loves to be run pretty hardcore nonstop. It's almost like a little nuclear power station in a sense, because it just wants to cover the base load. This is not designed to handle a big peak or valley. You could actually charge batteries or capacitors with a situation like this to handle a spike load.
Absolutely. So one of the things we're getting asked now from data centers is to load follow. Because when the grid doesn't have power, our big, drive in the market right now is to get these things as distributed power on site with data centers, off-grid, islanded. And so we are following peak loads. So it's peaky load when you're talking about artificial intelligence and AI loads. They're peaky loads. And we're doing testing. In fact, Dan here at the Experience Center is going to be testing that same thing.
Oh, cool.
To be able to follow this and do load following. And we've proven we can do it. So we're ready for it. The market's ready for us too.
So once this thing's heated up, it can actually do some dynamic stuff then?
It can. In fact, this is the last module we haven't talked about.
Yeah.
This is a super cap down here. And that really helps with balancing the load. So a lot of times when you have a fuel cell and you get a spiky load, it can actually absorb and expend energy in that first few seconds until the fuel cells take over. So if the load goes from between 30 and 80 and kind of oscillates, we can handle it.
Wow, so that's basically, Dan showed us a super cap cabinet in there, very similar concept to what's happening in here. And then what's all the way at the end? Is that just the controls?
Water deionization module. This is actually the little bit of water that we need. We actually purify the water and enter into the equipment, but it's very rarely used. Just in startup, maybe maintenance if we want to. Maybe if it goes down to really low levels, we might use a little bit of water, but we're water positive. We make water.
So let's say I'm a data center. I want to install, I need power now. I'm, full self-driving's coming. We need to power those computers, whatever it might be. How long does it take for you to drop this thing in, get it set up, and, get it rocking and rolling?
Yeah, that's a good question. So we can deploy systems that we publicize in 90 days. The truth is we build fuel cells all the time in our factories. We've got a gigawatt factory in Delaware. We got a gigawatt factory out in California. And we've committed to expanding. In our last earnings call, we're going to expand our capacity again because of demand. So we want to make sure that we can take the power to the market right now when it needs it the most.
And you were explaining to me earlier today as well about how companies pay for something like this. It's not, you can just outright buy it.
Oh yes, CapEx, you can buy it all day long.
But you could also have a sort of a payment plan.
We do, PPAs, power purchase agreements.
Yeah.
I think a lot of people like to do that. In fact, most of our install base are on 15-year PPAs. But we're being asked for a lot of bridge power now. A lot of companies are asking us for 5-year power, which we'll do a 5-year agreement as well. We don't have to do maintenance on the fuel cells in 5 years, so we'll just take it back. We'll refurbish it or we'll recycle it. 98% recyclable, so we can get it back.
Wow.
Absolutely. But yeah, we can do as low as 5-year PPAs, and you can buy it, and essentially you're paying a tolling rate, just like you would a utility.
Yeah, so you're just paying per kilowatt hour.
That's right.
And so what is a typical equivalent kilowatt hour rate of something like this? I would imagine it's probably a bit more than if you already had a high power transmission line sent there, but it can't be crazy because you also still need to run a business with something like this.
That's right. We can be competitive with any turbine business or any grid that's out there. I think when we first started out, we were in about 10 states where the electricity price is really high.
Yeah.
It pencils out really easy. But it's also very environmental friendly. It's no NOx, no SOx, no pollutants. So people in urban areas and easy permitting. You can't put a gas engine downtown in a city. It's hard to get permitting.
Good point.
We really get a lot of permitting, and also we have ITC credit.
Oh,
so
nice.
we actually, when a lot of people lost some of this benefit with the new the presidency, we actually still have ITC credit for fuel cells.
Amazing. Very cool. And so, what would you say would it be an average kilowatt hour rate? 20 cents per kilowatt hour?
It could be
plus minus?
We've seen it as low as 10
wow.
cents, 13 cents, depends on the application.
Yeah.
Whether you want carbon capture and heat capture. We didn't talk about heat capture.
Yeah, we should talk about that actually.
We should.
So up here you've got I don't know, it's pretty warm. It's not 800 degrees, so you're not going to get burnt.
80 degrees C on the top.
Yeah.
But we can channel all of the fuel cell heat to the back of the equipment. So if we walk on the back, there would be pipes coming out, and we can harness that about 350 degrees C. That's really good, high quality heat.
Yeah.
And then we can take that heat and put it through a heat exchanger. We can heat water. So we can do district heating, which we've done. We can heat water for district heating. Europeans now are faced with, I think it's 70% efficiency before they can actually install a system.
Oh, wow.
And so we have a combined system now that we can put out in Europe to do space residential heating and things like that.
I mean, it makes sense to do stuff with the heating. You can also use that heating to actually help with cooling for data centers.
We can, yeah. Absorption
really
chillers. So we can take, heat is energy. Take that energy, put it through an absorption machine, and you can actually make cooling, which is really bizarre for the non-engineers of the world. But yes, we are cooling our facility in Fremont, California right now.
Yeah.
Providing cooling, and data centers are asking for it. So we're doing quotations to do that.
See, that makes all the sense in the world to me. I mean, I would love to see this thing run off of straight hydrogen sometime. That's just not the reality of today's world in mass scale.
That's right.
So if you can burn natural gas more cleanly than other solutions, I think everyone would celebrate that.
Yes.
This is not a replacement for solar and battery storage. That's still needed in the marketplace. But having something like this where you can get real great baseload, non-stop power all day long.
That's right. And it's not burning. This is a chemical process. So it's essentially taking natural gas, air, water, quiet, chemical reaction, taking the hydrogen, making electricity. There's no combustion, no NOx, no SOx.
I love it.
Just clean power.
Yeah, we should also mention we're just having a casual conversation. This thing's running almost flat out right now.
Oh, yeah, it is. In fact, people come up to us all the time when we're walking sites and they'll say, "Is it operating?" I'm like, "Yeah, it's running." And they're like, "Where are the people?" I'm like, "We don't need people."
Yeah, it just runs.
Yeah,
And
where's the oil? There's no oil.
it pretty much, once you turn it on, you don't have to shut it off for 5-7 years. It just sits there and does its thing.
You don't have to shut it off for 20 years. You just
Oh,
have
wow.
to maintain the fuel cells, on a maintenance plan, make
Yeah.
sure that they're operating. So,
Dang, so cool. Well, I really appreciate the time. I'm so glad you were able to come out here and tell us about it, because I've seen this, like I mentioned, in LA at the convention center, and I was like, that is wild looking. First of all, they look cool.
Yeah.
Like, it's a great design.
it's a sexy refrigerator.
There you go. It's a sexy refrigerator. Yeah.
Yep.
And I'm like, what's going on with that? Well, now we know. So I really appreciate the time. Hopefully we'll
Absolutely.
come out. Maybe we'll do some more stuff with you guys. You have a massive site in Connecticut. Let's
We do.
actually show everyone that, if you don't mind.
Absolutely, yeah, we can do that.
And then we'll kind of wrap up this segment, because that site in Connecticut, how many of these do you have?
It's
a
20
ton.
megawatt.
Wow.
And it's a portion of it is using CHP to provide heat for a local industry, the cement plant next door.
So you're actually using the waste heat to
We
heat
are.
a giant plant.
Which could be 90% plus efficiency. So
That's awesome. Well, yeah, let's go show everyone that on the iPad, and then we'll wrap this up. We have got an iPad with a video, and the only reason that we're playing it on an iPad is I'm lazy about editing. So,
that's okay.
but we can at least show everyone some of the big stuff. So this is not AI. This is a real site
It's a real
in
installation.
Connecticut.
New
And basically the idea is they're all linked together, but this is the fuel cell itself.
Chemical reaction, very quiet. This is non-combustion. This is using the hydrogen. One fuel cell powers a light bulb. A stack powers a toaster. You stack them all together in a column, powers a house. Put the columns together, 8 in a column. You have the power module, which we saw outside. Mm-hmm. It can power a building, which is what it's doing now. That one power module is powering a
Right, so
building.
that was 65 kilowatts.
Yep.
And so each one of these essentially is 65 kilowatts.
Exactly. And this is power. This is like a 325 would power like a Home Depot or a big retail store. Mm-hmm. 100 megawatt energy server farm, power data center. Of course, our data centers are much larger than this now. Again, if you can build 100 megawatt, you can build 200, 300, 400, 500. There's no limit to how large we can go.
Damn. And you can stack
Less than
them
2 acres,
on
you can
top of
stack
each
them
other.
and double stack them. And you can do 100 megawatt in less than an acre,
Right. That's
which is really important
cool.
when you're inner city and you need the space. So.
Yeah, and I imagine getting high power capacity to city environments is probably the hardest possible thing to do.
It is. You got to put the power where the power is needed. And so you don't always have the luxury of being out in the rural areas.
Very cool. Well, I'm really glad that we got to see this. This is a cool video. I'll leave your website in the description below so people can learn more. Okay. And I really want the viewers to comment if we should go visit these guys. And I want to go to the Connecticut site. I think that is cool. My parents don't live far away from there.
New Britain.
Yeah, so that must just look like a sea of those power
It's
modules.
20 megawatts, and it does CHP again for that local cement factory, giving heat to that local cement factory, which is great. But that's a utility application. That's the customer's utility. So
very cool. Well, thank you so much for the time. That was a really big learning experience for me. So super cool. We'll do more with Bloom Energy coming up. Time to get back to Dan and finish up this video.
all right. Thanks.
We are back inside another cool area of the building, Dan. We've shown this in a previous episode on the channel.
Yeah, a little bit of the utility substation area and everything.
I've got to ask you, I know you don't want to show this, but you got to tell us what's going on.
Oh, with the electric vehicle?
This is just kind of cool.
Yeah, this one, we had originally done a vehicle to grid thing with it. So we had a 20 kilowatt hour battery in this little mini truck, and we did a connection through some inverters here, put it back into the grid, and we were showing how we could power our home with it. So this is about 3 or 4 years ago. We actually, during COVID, we were playing with stuff like this, so it was a good opportunity for us to try something different, and worked out really well.
I love it. It's super cool. And then of course you've got, you know, your busway charging on display here, which we've shown a lot of this EV charging apparatus. But one thing that's really cool about coming here is I get to learn all about the integration of stuff, but then also arcing. We're going to end with that, with a giant flash. But maybe you can explain what's happening here, because this is basically a mini version of your whole building.
Yeah, this is sort of the when I referenced the microgrid, this is the microgrid. So if you kind of look in terms of the colors here, the green is the solar. So of course it goes up and down. We're hitting the peak of the day right now, and today, this was yesterday. The red is our load. So it's bouncing up and down with air conditioning and everything. The blue is the batteries, and you can see later in the day yesterday, we kept the yellow, which is a utility, flat, kind of like we did with that large UPS in the other room. So we kept it at 15 kilowatts. So our load back here is only like 30 kilowatts max, or maybe a little bit.
It's just a little demonstrator.
Yeah, so it's a demonstrator, but this is an actual working microgrid. So we have right now 10 kilowatts coming from the utility, 21 kilowatts of load, 13.5 kilowatts of solar, and if we needed to, we could discharge the battery. So it's a kind of cool visualization. We're going to do that for the whole building, and that'll be the next step for tying in all those different sources. But we thought we'd end with a little bit of a bang here. You know, there's a spark gap up there, and we talk about the flashover for voltage being about 10,000 volts per centimeter. So this unit can put out 100,000 volts.
Did you
right
make this?
now?
Do people just sell boxes like this?
Yeah, we use it for testing electrical equipment. So it's not, most people don't own one of these. But,
Okay,
but anyway,
cool.
we're at 60,000 volts now.
Right, and so when you say 10,000 volts per centimeter, that is in ambient air.
That's in ambient air. That's burning the air and actually ionizing the air. So in a vacuum bottle that we have other stuff where there's no air in there, we can do 30,000 or higher voltage in a little spark gap like that between the electrodes. But when we suck the air out, we can do that. But in air, you're going to see this thing flash over at about 85,000 volts.
All right, well, I'll let you crank it up to about 85.
So we're up to almost 80.
Damn.
There you go.
Crack. That's awesome.
So the cool thing again is to be able to demonstrate that, and if we and just to show kind of the point here, if we reduce this gap to something
so you're actually
smaller,
bringing it closer together.
Yeah. We can kind of run it up and do where it won't flash over; it'll just continue to arc.
Oh, okay.
And that's you know,
nice.
And then we could trip the breaker, you know, like here, and that's the goal, is to be able to show, like, how do we break arcs? And so a lot of the stuff we do is arc interruption, and whether it's fuses, breakers, contactors, light switches, everything.
And that's what a lot of the reason to have all that switchgear is for.
Yeah, exactly. I mean, you have to, and that's air. Some of the low voltage stuff is air insulated, and then as you get to the medium voltage stuff, to make it practical in size, we use vacuum. So
right, and I would imagine if you're using air, they're altitude rated as well.
Yeah,
because the
so
higher you go,
have to derate stuff in certain areas and stuff like that.
Yeah, makes sense. Very cool. Well, this was such an informative visit, as always, when I come here. Thank you also for installing that Bloom Energy thing.
That thing's really cool, isn't it?
That was cool. I think it's like, you know, I'm just not thinking about large scale power all that often. And for that application, that is really cool. Data center stuff, anytime you need that huge base load, that's really cool.
Yeah.
I'd love to see you get a nuclear reactor.
Actually, Westinghouse Nuclear is right across the road down here.
Oh, yeah?
They're making the small mini nuclear reactors.
Dude, you got to install one.
You never know. I might have to get a 250 kilowatt one.
Yeah, that would be
I mean, that would be the ultimate goal before I retire. I'm going to shoot for that. But
okay,
we'll see. I'll let you know.
Sounds good. Well, thanks as always to the viewers. If you want to see more stuff, let's convince Dan to do a YouTube channel with us going through all of this. And thank you all for watching at home. We'll see you in another one again soon. Bye-bye.